Consider the triangle ABC. The points PQ and R are the midpoints. Let OA vector be A vector, OB vector be B vector, and OC vector be C vector. Find BR vector in terms of A vector, B vector, and C vector. So we need this vector, and we can see that BR vector, using the rule for difference, it's AR vector minus AB vector, or you may use a rule for the sum, triangle rule for the sum, and you may write that BR vector is BA vector plus AR vector. But we don't know BA and AR, and we need to find it. How to find it? It is given that OA vector is A, OB is B, and OC is C. But what is OA vector? It's a position vector of a point A. It means that there is the origin somewhere, so that vector from the origin to the point A is A vector, vector from O to B is B vector, and vector from O to C is C vector, and hence we can find AB vector. It's directly the difference, it's B minus A, or again, if you use a triangular rule for the sum, AB it's AO plus OB, and AO it's minus A because opposite direction, plus B. So we can write that AB vector is B minus A, BC is C minus B, and AC is C minus A. Hence, BR vector becomes BA, it's minus AB, so it's A minus B, plus AR, and AR it's a half of AC, which is C minus A, because R is the midpoint. Hence, it becomes A minus a half, so it's a half A minus B plus a half C. The next, find the vector equation of the line that passes through B and R in terms of A, B, and C, and the parameter lambda. So we need lines through BR, and we know that to write a vector equation of a line, we need the position vector of any point on a given line. We can use, for example, a point B, its position vector is just B vector, plus a direction vector. What is a direction vector? It's any vector which is parallel to a given line, and we can consider BR as position vector. So the required equation of the line through BR becomes R, let it be R1, because the next question is to find another line, another equation of a line, and its position vector of B plus lambda BR, and it becomes just B plus lambda, and this result, it's a half A minus B plus a half C. And the next question is to find a vector equation of the line passes through A, Q, and A and Q. And again, it will be position vector of point A, which is just A, plus mu, and the direction vector, and it can be considered to be the vector AQ. And what is AQ? AQ is AC plus CQ, and CQ is minus QC, and QC is a half of BC minus a half of BCC minus B. Hence, it becomes half B minus half C. half b minus half c. Half b minus half c and plus ac, which is c minus a, which is c minus a. And hence it becomes a c minus a half c, so it's plus mu c over 2 minus a plus b over 2. And the next hence shows that OG vector is 1/3 of a plus b plus c, given G is the point where BR and AQ intersect. So G is this point, it's a point of intersection of two lines, and let's find coordinates of a point G, hence position vector can be easily found. And since it's a common point, we should consider simultaneous equations for two equations of the given lines, and hence we need just equate these equations, so it becomes b plus lambda over 2a minus lambda b plus lambda over 2c is a plus mu over 2c minus mu a plus mu over 2b. And equality can be only if there are same coefficients in front of same vectors. It's similar to the situations when one polynomial is equal to another polynomial, and hence equality can be only if there are same coefficients in front of same powers of x. So let's consider vector A, so it becomes lambda over 2 is A is equal to 1 minus mu. For B, 1 minus lambda is mu over 2, and for C, lambda over 2 is equal to mu over 2, and from the third we can see that lambda is equal to mu, and let's consider the first, hence it becomes lambda over 2 is 1 minus lambda, and 3 over 2 lambda is 1, so lambda is 2/3, and hence mu is 2/3, but we should check the third equation, the system to be consistent. Otherwise, if the third equation is not true, it means there is no point of intersection, lines are skew. So we need check this, so it becomes 1 minus lambda is 1 minus 2/3 is equal to half of 2/3, so it's true. Hence we can see that when we equate two position vectors, finally if we substitute lambda or mu, it doesn't matter because it's a common point, we get a position vector on a given line, and hence it will be a position vector over a point G. And actually we don't need directly coordinates of a point, because we cannot find coordinates of a point. I said it's a bit not correct. So we can find directly position vector of OG. Hence it becomes B plus lambda, which is 2/3, a half A minus B plus a half C, and it becomes B plus 1/3 A minus 2/3 B plus 1/3 C, and it is equal to 1/3 A plus B plus C as required. The next shows that the line segment CP also includes the point G. We can show that CP includes point G, and for example we can show that points C, G and P lie on the same line, hence PC includes G. And how to show that 3 points lie on the same line? We consider vectors, for example CG and CP, and if we show that CG is some constant multiplied by another vector, it means that vectors are collinear, and it means that they are parallel in general. It's similar to be, it's likes to be parallel, and it means they are parallel and lie on the same line, but they may lie on parallel lines. And if we say that since there is point C is a common point, hence P, G and C lie on the same line, and hence P C includes G as required. So let's find it. What is CG? CG, and since again position vector OG is given, it's 1/3 A plus B plus C, and OC it's C, so CG it's OG minus C. Or you may apply triangle rule for the sum, so minus C. Hence it becomes 1/3 A plus 1/3 B plus 1/3 C minus C, so minus 2/3 C. And what is CP? CP it's CP from C to P, so it's CA, which is A minus C, plus a half OAB, and it's just B minus A, so half B minus a half A. Hence it becomes a half A plus a half B minus C. And we can see that CG is 2/3 over vector CP vector. Hence, and also since C is a common point, it implies that 3 points lie on the same line, and hence BC includes G as required. The coordinates of the point ABC are given. A point X is such that Gx is perpendicular to the plane ABC. Given the tetrahedron ABCX has volume 12, find the possible coordinates of X. So there is base A, B, C, and somewhere is point X, and in general it may be here or above the triangle or below. Hence you may suggest that there will be 2 solutions for X, for point X, and tetra means 4 tetrahedrons. Hedron, it means there are 4 faces, and it's actually a pyramid where the base is a triangle ABC, and Gx, it since it's perpendicular to the base, it will be a height, and volume, it is given that it's 12, it's 1/3 area over base times height. And we can find Gx firstly, so let's find area over given triangle. Area formula is given in the data booklet. It's a half multiplied by the magnitude of the vector, which is cross product of 2 vectors, for example AB and AC. It may be BA, BC, or CA, CB. And let's find a cross product. You may use the formula from a data booklet. I use another technique with the determinant of 3 by 3 matrix IJK, AB vector, and AB vector becomes just endpoint minus the initial point, so it's 3 minus 1, 2, 7 minus 3, 4, negative 5 minus 1, negative 6, 2, 4, negative 6, and AC 2 minus 1, 1, 2 minus 3, negative 1, and 1 minus 1, 0, and it becomes I, and determinant of this 2 by 2 matrix, it's this product minus this product, so it's 0 minus 6, negative 6, minus J, determinant of this 2 by 2 matrix, it's 0 minus negative 6, so it's plus 6, plus K, and determinant of this 2 by 2 matrix, it's negative 2 minus 4, negative 6. And magnitude of this vector, and hence area becomes a half. Magnitude of the vector, it's a square root of the sum of squares of its coordinates, so it's 6 squared, or negative 6, it doesn't matter in general, plus 6 squared, or 6 root 3, or 6 root 3, and finally it's 3 root 3. Hence, the length of Gx, we consider it as a line segment, or we can consider as magnitude of a vector, it doesn't matter. So it becomes 12 multiplied by 3 divided by area, 3 root 3, so it becomes 12 divided by root 3, or if we multiply by root 3, we get 4 root 3. And we can consider gx as gx vector and its magnitude, which is 4 root 3. And what is gx vector? Since gx is perpendicular, and we know that if we consider cross product of two vectors which lie in the plane, the result is perpendicular to the plane, and hence it will be parallel to gx, and we can consider gx as some coefficient multiplied by the vector in this direction, because our gx vector will be parallel to this vector. And we can see that we can consider it as 1, 1, 1. So it's not correct to say, because it's coordinates, so it's magnitude 4 root 3, but coordinates are some constant 1, 1, 1. So it's some because it's unknown constant, and depending on this constant we will get the required length, but this vector will be parallel to this vector, and it means that if two vectors are parallel or collinear, their coordinates are proportional. And since it is known its magnitude of gx, it's the sum of squares of the coordinates, so it becomes k root 3, and it should be equal to 4 root 3, hence k is 4. So hence gx vector has coordinates 4, 4, 4. So there is, or we can consider, for example, origin, and if we consider OG as position vector, it's 1/3 A plus B plus C. It's this result, OG vector. And we know gx vector. But it may be up or above the triangle or below. So in general, we can consider as plus minus to take into account possible two possible directions. So OX position vector of point X, it will be OG plus minus GX, or plus minus 4, 4, 4. And we need the OG vector, it's 1/3, and the sum A plus B plus C, so it's A plus B plus 4x coordinate, it's 1 plus 3 plus 2, it's 6 over 3, it's 2. And for y coordinate, it's 3 plus 7, 10, 12, 4, and z 1, negative 5 plus 1, 2 minus 5, negative 3 over 3, negative 1. Hence OX becomes 2, 4, negative 1 plus minus 4, 4, 4. Hence the first possible position vector OX becomes, if we consider plus, so it becomes 6, 8, 3, or when minus, it's negative 2, 0, negative 5. And since it's a position vector, possible coordinates become 6, 8, 3 or negative 2, 0, negative 5. 6, 8, 3, negative 2, 0, 5. Yes, it's correct. And that's all for the question.